This video will cover trig differentiation, which forms part of the AP Maths syllabus. When we're looking at trig differentiation, it's important to understand the set criteria or the set rules that govern the derivative of the following trig functions. Please note that you do not need to know these rules off by heart, as the formula of these, both the original and the derivative, are given to you in the formula sheet. But anyway, I'll go through them just so that you understand my answers in the coming minutes. So the derivative of sine x is cos x, the derivative of cos x is negative sine x, the derivative of tan x is sec squared x, the derivative of cot x is negative cosec squared x, the derivative of sec x is sec x multiplied by tan x, and the derivative of cosec x is negative cosec x cot x. Then I'll now go through some examples to help illustrate these rules practically. There isn't much more to it, so I hope these help. If we're given a function f of x is equal to tan 3x and the question asks us to find the derivative, it's very easy. We obviously say derivative. Then if we go back to our table, we can see that we've got a tan 3x, so the derivative of tan x is sec squared x. So we obviously say sec squared 3x because it's given as a 3x. Then we multiply it by the derivative of the angle. So the angle is obviously 3x. So the derivative of the angle is 3. Then if we move on to the second example, it's asking us to derive x cubed plus 3x multiplied by tan x. We can immediately see that we need to use the product rule here. So we drop that down, we derive the first term. So obviously 3x squared plus 3 coming from this first bracket, derivative of the first bracket, multiplied by leave the second, which is obviously tan x, plus by leave the first, we take the bracket there, leave the first, multiplied by the derivative of the second. Derivative of tan x is obviously sec squared x, which you can see in this table. Then if we move on to the third example, getting progressively harder, we ask for the derivative of the square root of sine 3x minus 1. Obviously we know with derivatives, we don't like square root signs, so we rather put that to the power of a half. Then we use our chain rule, we take the half into the front, rewrite out the whole bracket, minus 1, so a half minus 1 is negative a half, multiplied by the derivative of what's inside the bracket, the derivative of sine 3x minus 1. We can go back to our table, the derivative of sine x is cos x, so the sine 3x minus 1 will become cos 3x minus 1. Then we also need to get the derivative of the angle. The angle is 3x minus 1. So the derivative of this angle is 3. Then our fourth and final example for this section is probably the hardest example you could get as a test question. So if you can do something like this, you should be well prepared for a trig differentiation section of a test. We ask for the derivative of x multiplied by sine x over 4x squared. Here is a chain rule, a product rule within a quotient rule. So when we're looking at the bigger picture, it's obviously a quotient rule. We've got our top term and our bottom term, but our two top terms form in themselves a product rule. So what do we do with the quotient rule? We derive the top term. Now watch carefully. Deriving the top term, we leave the second term, so we leave the second x, multiplied by the derivative of the first term, which is x, plus by leave the first term, which is x, multiplied by the derivative of the second term. So the derivative of sine x is cos x, obviously using that table from the beginning. Then we leave the bottom term, which is 4x squared, minus by leave the top term, which is x multiplied by sine x, multiplied by the derivative of the bottom term, which is obviously hop the 2 down and we get 8x, over the bottom term squared, so 4x squared, which comes out to be 16x to the power of 4. Hope this video helps. Please do not hesitate to contact us if you have any further questions. Thank you very much.